Rahim. Assalamu alaikum, dear students. This is our next problem. Problem having been once again chosen from the same book, that is Modern Physics by Kenneth S. Crane. Okay. First we will follow this book, then we may start Modern Physics by Andrew Rex and Stephen T. Thornton. Then we may start Modern Physics by Arthur Weiser. Okay, then we may start Modern Physics by Paul A. Tipler. Then we may start Modern Physics by Randy Harris. Okay, anyhow, we come towards the statement of our problem. Okay, in designing an experiment, you want a beam of photons and a beam of electrons with the same wavelength of 0.281 nanometer. Nano standing for 10 to power minus 9 meter. Okay. Sorry, I have made a slight mistake. Nano does not stand for 0.10 raised to the power minus 9 meter. Okay. Nanometer stands for 10 to power minus 9 meter. Simply nano does not include meter. Okay. Equal to the separation of the sodium and chlorine ions in a crystal of sodium chloride. Okay. Dear students, actually basically this thing deals with the chemistry, and I taught chemistry in a formal manner, in a regular manner up to the year 1986-87. Okay. Despite this, I am pronouncing correct that combinedly it is called sodium chloride, but separately these elements are called sodium and chlorine. Okay. Find the energy of photons and the kinetic energy of the electrons. Okay, so we have to find out two things: energy of photons and the kinetic energy of the electrons. For removal of any doubt, we take the statement once again. Okay. In designing an experiment, you want a beam of photons and a beam of electrons with same wavelength of 0.281 nanometer. Okay, beam of photons and beam of electrons and the same wavelength. Okay, equal to the separation of the sodium and chlorine ions in a crystal of sodium chloride. Okay, find the energy of the photons and the kinetic energy of the electrons. Okay, dear students, in this problem there is nothing new. Problems which we have solved previously completely cover this problem. Okay, so even if we skip this problem, it will not be very inappropriate or unsuitable. But if we do not exclude and rather include in our list of video lectures problem solving, okay, then it will be more helpful, definitely. Okay. Anyhow, we come to its statement. Oh, sorry, solution. But before coming to its solution, we as usually first come to tools, helping tools, toolkit. In this problem we have used three tools, okay, and all these three tools have been taken or chosen so many times that it will be inappropriate to discuss them in a detail, okay. It will be sufficient if I say that please refer to my previous videos, but students, if some viewer on YouTube is watching my video first time, then it will not be appropriate for him or her, it will not be facilitating for him or her, okay. So keeping in view circumstances of new viewer on YouTube, I shall go through these helping tools in a manner as if these tools have not been used or utilized in my previous videos, okay. So newcomers on YouTube should also respond positively, keeping in view this approach on my and on my side, that I am taking into consideration their facility and their difficulty, okay. Oh, yes, now helping tool number one. In helping tool number one, nothing is except the definition of momentum of a photon, okay. Momentum of a photon denoted by P is equal to E over C, where E is photon energy and C is speed of light in vacuum, okay. This expression alternatively becomes equal to HF over C, where H is Planck's constant and F is frequency. C as usual is speed of light in vacuum, okay. This expression alternatively in the third stage becomes equal to H Planck's constant divided by lambda, that is wavelength, okay. We know that frequency and wavelength are inversely connected with each other with the involvement of C, speed of light, okay. Frequency is equal to C over lambda and lambda is equal to C over F, okay. F is equal to C over lambda and lambda is equal to C over F. Now we move to second tool. This tool has also been taken so many times that I think it is enough if this tool is shown on screen, okay. From this tool we will use this value, okay, electron 0.511. In place of mc square we will use this value which is in million electron volt, okay, but usually we convert it in electron volt, so we will take this value as 511000, okay. Now we move to third tool, which has also been chosen so many times in our previous videos, but just in order to facilitate newcomer on YouTube, it is once again discussed in a little detail, okay. In this table, the speed of light c equal to 2.998 into 10 to power 8 meter per second is given, which will be used in this problem, okay. Here Planck's constant h is also given in two different systems of units, okay. We will use second alternate expression, okay, 4.136 into 10 to power minus 15 electron volt into second, okay. Moreover, this is given electron mass me 5.4 into 10 to power minus 4 u. This alternative becomes 0.511 million electron volt over c square. This may also be used okay, may be used. Next, combined result of H and C is also given here. Okay, this combined result is not necessary, okay, because these two values are separately given, and if we multiply these two we will get this value. Okay, so it is our discretion whether we take this combined value or a separate values. Okay, now we move to its solution in a regular manner, okay, proper manner. We know that tool number one, in which momentum of a photon is defined. Okay, we know that momentum P is equal to E over C is equal to HF over C is equal to H over lambda. Value of H is given in tool, in where it is expressed into different system of units. Okay, and we have chosen second alternate value, equivalent value of Planck's constant H. Moreover, value of lambda is given in this statement, which is 0.281 nanometer. We know that nano stands for 10 to power minus 9, so we have just used this value here. Okay, in the next step, up to this we have made no change, but we have just made an alternate arrangement that we have multiplied and divided by C. Okay, it will not make any difference. Okay, because both these equal quantities will cancel each other and we will revert to only this expression. Okay, the only difference is that in the numerator we have used value of C in terms of meter per second, that is 2.998 into 10 to power 8 meter per second, but in the denominator we have kept C as it is. Okay, we have not used its equivalent value in terms of meter per second. Okay, so dear students, here second will be cancelled with second. Okay, meter will be cancelled with meter, and we will be simply left with electron volt over C. Okay, so our the result becomes 44.127 into 10 to power 2 electron volt over C. Okay, actually dear students, because 10 to power minus 9 is in the denominator, when it will be shifted to a numerator, then it will become 10 to power plus 9. Okay, 10 to power plus 9 and 10 to power plus 8 will become 10 to power 17, while this is 10 to power minus 15. So 10 to power 17 will overcome or predominate by 2 steps. Okay, that is 10 to power 2 will remain. 10 to power 2 means 100. Okay, so when it will be multiplied with 10 to power 2, we will get 4412.7 electron volt over C. Okay, this is 100% correct answer, but just as a fashion, we reshape this expression as 4.4127 into 10 to power 3 electron volt over C. Okay, because usually we denote quantities in terms of multiplication of 10 to power 3 or 10 to power minus 3, 10 to power 6 or 10 to power minus 6, 10 to power 9 or 10 to power minus 9, 10 to power 12 or 10 to power minus 12, 10 to power 15 or 10 to power minus 15, 10 to power 18 or 10 to power minus 18, 10 to power 21 or 10 to power minus 21, 10 to power 24 or 10 to power minus 24. Okay, and dear students, this figure that 10 to power plus 24 or minus 24 is 10 to power plus 24 is so large quantity that we can only imagine it in our mind. Okay, this is just jugglery or magic type things. Okay, 10 to power plus 24 and 10 to power minus 24, We can only understand these things from mathematical point of view. Otherwise, if we imagine them in a physical manner, it will be very difficult for us to adjust these things in mind, okay, because these are magic like things. Any but these things have been proven till now, so we also accept them as they exist. Anyhow, this was a quite separate discussion, okay. So its answer has become equal to 4.4127 into 10 to power 3 electron volt over C. Okay. Note. What note? Both photon and electrons have equal momentum, because statement is a very similar for photon and electron, and their wavelength is also same. So from statement we can conclude or say that both photon and electrons have equal momentum, that is 4.4127 into 10 to power 3 electron volt over C. Okay, now we move forward. Okay, now energy of photon is E equal to Pc. Value of P is given in the above line. Okay, so here we have just multiplied it with C, okay, because that is P and E is equal to Pc. So when we will multiply it with C, then C in its denominator will be cancelled, and our energy of photon will become equal to 4.4127 into 10 to power 3 electron volt. What is the difference? The difference is that in case of momentum, C was in the denominator, but in case of energy of photon, C is not in the denominator, it is in electron volt. Okay. Now let us calculate the kinetic energy of electrons as under. Okay, for calculating the kinetic energy of electron, we will have to make some arrangement. That arrangement depends on classical values. Okay, classical, when we use the term classical, we usually mean that we are working within the philosophy of Newton. Okay, when we use the term relativistic, then it means we are working within the philosophy of Einstein. Okay, classical versus relativistic means Newton versus Einstein. Okay, now let us calculate the kinetic energy of electron as under. For calculating the kinetic energy of electron, we have to make an arrangement within the classical parameters. Okay, in classical mechanics or classical physics, we know that kinetic energy is equal to half mv square and momentum is equal to mass into velocity mv. Okay, when we solve these two equations simultaneously, we get a third expression, which is k equal to p square over 2m. In the next step, we will multiply and divide it with c square. Okay, this implies that k is equal to p square over 2m. To this extent, we have not changed the previous step, but we have divided and multiplied it with c square. Okay, in the next step, it will become p square c square, or in other words, pc whole square. It can also be written. Moreover, in the denominator, it will become 2mc square. Okay, we have found the value of pc above. Is there need to go back or not? pc this. Okay, this pc. Okay, so in place of pc we have used this value. Okay, divided by 2 is the same as it is. However, in place of mc square we have used this value from the tool which we have described in the starting part of this video. Okay, in that table value of mc square for electron is given in million electron volt, that is 0.511 million electron volt, but here we are using that value in terms of electron volt. Okay, so in place of 0.511 we are using 511000 because in the numerator there is a square of electron volt, and in this way when electron volt will appear in the denominator, then one electron volt will be cancelled. Okay, so a simplification of this thing gives us this result. Okay, 19.47 into 10 to power 6 electron volt whole square divided by 1022000 electron volt. Okay, here electron volt, one electron volt will be cancelled and only one electron volt in the denominator will be left, and our answer will become K equal to 19.05 electron volt. And this is the end of our problem, and this is the end of our video. Okay, till next video, Allah Hafiz.